introduction, and I will take a step back from laws and regulations and go a bit into research projects at the DLR. Not only research, but also what we're currently applying really in the domain of satellite operations. So what that is, hopefully you'll understand after, and what we're doing here, and how we are pushing space boundaries better. So rough agenda of the talk. First, I'll present what is the DLR, what is the GSOC where I work, the German Space Operations Center. And then we'll stay on the ground still. So we will stay on AI for ground operations. How do we apply it there? And there we'll present the first anomaly detection system, which we are using in operations right now. Then we'll go one step further up, AI for operations in the orbit, so AI on the satellite, and present a use case in a current research project in that domain. Then even further up, we'll go to human spaceflight. Right now, human spaceflight is not really further up, it's still in orbit. But next year, Lunar Gateway is launching, and we are also talking about Mars and beyond with human exploration. And I'll also bring a research project which we currently have at DLR as an example for where we can apply AI there, and give a short summary and outlook. So DLR and German Space Operations Center. So before we had Polytechnique Montréal with 10,000 students. DLR has 10,000 employees over all of Germany, so lots of research institutions, over 50 institutions, institutes, over 30 sites all over Germany in lots of different areas. So it's not only aerospace, we also have research in safety and security, research in transport, research in digitalization, energy. For example, in Cologne, we have a solar power plant for research purposes. But of course, there's also lots of institutes related to aerospace. So all of the orange ones here are related to aerospace. And maybe since the topic is AI, we have, to name a few, institute funded, I think 3 years ago, the Institute for AI Safety and Security, also a big topic at DLR, Institute for Quantum Technologies, which also ties together with AI these days, and also bring an example in that domain. And Institute of Data Science in Jena also funded, I think, 3 years ago. And there's lots of synergies here. So for example, we now have a project together with an institute that did reservoir computing, which goes into the AI direction for forecasting telemetry on a satellite. And they did a completely different topic for chaos forecasting, chaotic systems. We talk to each other, and now we have a proper project together. So there's lots of synergies that stem from all these institutes at the DLR. Coming to the space operation facilities, so German Space Operations Center is where I personally have worked for 9 years now. But we also have the MUSC, the Microgravity User Support Center in Cologne, astronaut training center also in Cologne. We have our own ground stations in Weilheim by Munich, but also our mobile rocket bases. So we launch our own and build our own sounding rockets and launch them for microgravity experiments. So coming to AI for operations on ground. So what is satellite operations? So if you think about if you drive a car, satellite is like a car, just you have to drive it remotely. You can't do an oil change. You can't do something if there's a light that flashes. You can't look at it. You can't exchange anything. So all of the stuff has to be managed and controlled by ground. And this is the same for a satellite. So the satellite flies through space. And what we do at the GSOC, so this is one of our control rooms, we try to keep the satellite alive and perform the mission objectives safely so that the satellite stays healthy. And to this end, we also apply AI. So one of the use cases that I brought with me is the automated telemetry health monitoring system, which is actually, we started this project 6 years ago, and maybe to tie back to Canada. The colleague who originally started this together with myself, he's from Canada, from Ottawa, now a former colleague, but we started this together, and he's now working at a different company doing AI and quantum, the quantum domain at a different company. But the goal here was to automatically do monitoring of satellites. So modern satellites, say Grace follow-on satellite, which we launched together with NASA in 2016. Each satellite has around 80,000 telemetry parameters defined. So one telemetry parameter could be temperature, top right. The other one could be rotation speed. The other one could be power consumption, and so on. And all these parameters have to be monitored optimally, which is currently or has currently been done mostly by humans and by static checks. And we wanted to apply AI here. So what we did is we wrote our own custom detection algorithm. We solved, for us at least, the problem of having no training data, basically no labels. We developed our custom front end for the users, because just detecting it, there's nothing gained. You have to bring it to the users, to the subsystem engineers, who can then work with the results and analyze, is this really a problem? How do we fix it? And in future, maybe one step further even, we will also go into space probably next year and try it on board a satellite. The other topic that I brought with me is quantum technology. I just want to briefly touch this because some of the problems that quantum technologies solve these days are also solved by AI. For example, mission planning tasks, which are in the end constraint satisfaction problems, can be solved by quantum computers also, and we also have research there. For example, shift planning, to name an easy one, but also planning onboard timelines on board a satellite efficiently, and also quantum algorithms for anomaly detection. Other areas in future will be quantum key distribution. We heard about post-quantum cryptography, also a big topic about satellites. But you can also model the satellite's attitude and orbit control with quantum states, for example. But this is just to briefly mention that this is also an active area of research. Let's go to in-orbit, the on-orbit domain. So if you do something in orbit, you don't have to do it on ground, and you gain the benefits of not having to have the delay of reaction. So you can basically react in real time if you do it in orbit. And this is exactly what this project that I want to present does. ODARIS, the onboard data analysis and real-time information system. So we heard before fire detection, for example, as a use case. You can also do this with this in the future, or not do the exact same thing, but maybe contribute to it. So the plan here is to bring AI on board the satellite to do object detection or fire detection, for example. And then in real time, if it detects something, send alarming messages, for example, per SMS to the local authorities. And with that, you basically have almost instant reaction time. And we will launch our first 2 experiments in 2025, I think, with this use case. The use case depicted here is the typical piracy, human trafficking, and so on detection for ships. So you see a ship which is not registered, you send a message to local authorities, tell them, hey, there's a ship which we don't know about. Do you want to do something? And then the authorities also have the options to actually do a bidirectional communication. So they don't only receive, but they can also send to the satellite to get new information and further information about the detection. But this can also be done with fire. So for example, it detects a fire, it can send the local authorities, hey, there's a fire starting here, and then they can react on it. So you basically don't need ground anymore, you can directly act on the implication. So coming to human space flight, so at GSOC we also command the Columbus module on board of on the ISS and speak with the astronauts daily. So we have lots of experience here. And what is currently done in human operations is everything is done on ground. So we have 24/7, 365 days a year on ground operations and control, and doing everything that the astronauts don't have time, don't want, or can't do. So maintenance tasks, turning something on, off, checking that air supply is good, all of that has to be planned, preparing experiments. So all of this maintenance work where the astronaut time is too valuable for them to do. This is done currently on ground. But if you look further into the future, we can't do this on ground anymore. And maybe we don't even want to do it now in the near future because it's also not so cost efficient. For example, if we look at an increment for the ISS, 6-month increment with experiments, the training starts, I think, 5 years in advance, and all the staff has to be trained also on ground. So it's lots of money, lots of time, and we can really save if we try to go into the intelligent systems. And in the future, if we think about Mars missions, the delay between Earth and Mars is 5 to 20 minutes roughly for just one direction. So you can't do on-ground operations anymore, just not feasible. You have to do it on the spacecraft. And if you want to do that, you can't really bring people on board to do only maintenance tasks because people are expensive, they weigh. You have to train them, and you actually want to use the human resources for experiments and for the science stuff and for the cool stuff. And you can't do this anymore if you have lots and lots of maintenance engineers on board. So what we have is we have a research project, which is currently a joint PhD project together with the industry, which tries to replicate this human decision-making process with AI methods. So the monitoring, reacting to the monitor telemetry and automatically performing action, so planning action based on the monitoring. Those are handled in a multi-agent system in this thesis and will be probably a project further on after the thesis is finished. But the goal is to do everything that's done right now on ground by humans, replicate it with an AI system in some parts. In some parts, more case-based reasoning and other methods, and then try to really have an onboard system that replicates and takes the weight of the astronaut shoulder for future space operations. So with that, I'll come to the summary and outlook, and I'm a bit over time. I hope it's not, I didn't get a sign, nice. So short summary and outlook. AI is already used today in space operations and will also play a role in the future, because when you think about pushing the boundaries of space, which is the topic, it's not only about pushing to Mars, it's also about pushing the number of satellites, the efficiency of operations, and so on. And for all of those topics, AI plays a major role. And on the counterpart, AI also has lots of unique challenges, because in the space industry, there's no real training data. You don't have thousands of cars of the same model. You have one satellite of one type, and that's it, especially in the research domain, if you don't think about Starlink and so on. And all of those challenges are sort of unique, and you have to face them step by step. So with that, that's the end of my talk, and thank you for the attention.
Thank you, Leonard.